Around 2 weeks ago, I started working on a pathtracer project. I was looking for something to work on and remembered the guide Ray Tracing in 1 Weekend by Peter Shirley. It's a write-up, a book really, on how to make a pathtracer from scratch in C++. Before talking about the features that Photon has and the images that I rendered, it's important to tell you what a pathtracer actually is and how it functions. A pathtracer is a tool to render virtual scenes. You input settings for the objects that make up the world, and it outputs an image, as in this Cornell box. It works by creating rays that go out of the camera into the scene, intersect with scene geometry, and bounce off of that geometry over and over, accumulating light along the way. By generating many rays per pixel, a pathtracer can create a very realistic image. At the end of ray tracing of 1 Weekend, I had a small pathtracer that could render simple scenes composed of spheres. I added support to output.pngs and implemented a system for triangles based off of this lecture paper by the University of Washington. I then wrote a system for importing .obj files so that I could render 3D models. Finally, as rendering was taking very long, I added CPU multithreading so that the code is run in parallel. This means that the image is broken up into chunks and then each chunk is rendered at the same time. This resulted in around a 12x speedup. Here's a short gallery of some of the images I rendered. I created these scenes by mocking them up in Blender, exporting the models individually, and then configuring them in the renderer. This is the Stanford Dragon, a common rendering test model, and a multicolored box. The dragon is composed of just under 250,000 triangles, and the render took a little under 5 hours to complete. This is another Stanford test model, Stanford Lucy. It is rendered in glass with a bright torch flame, a dark background, and a backlight. This is a render of a Miata I found on Sketchfab, created by Lexi C16. I split it up into sections based on material and added them into the scene function. As for the thumbnail image, I created the text in Blender and then split it up letter by material. In the future, I'd like to implement GPU multithreading with CUDA to speed up the pathtracer significantly, as well as Monte Carlo estimation, texture support, and better support for importing 3D scenes. If you are interested in writing your own pathtracer or exploring the mechanics of how they work beyond the very simple explanation in this video, I highly recommend reading through ray tracing in 1 Weekend. In addition, the book Physically Based Rendering is often referred to as the Bible of pathtracing and is a wonderful breakdown on how to make an advanced ray or pathtracer. I've linked these and some other great videos on these topics in the description, as well as my code on GitHub. With that said, I hope I've piqued your interest in rendering and have a great rest of your day.